Data about neuro disease. The platform is very simple. We just collect data as a kind of Google Forms. The goal is the data, the side effects of the data. But it's like the challenge is the data around countries, different rules. As I said, like, you have to just push back all the time. Or you can do this, you can do that. You have 1 year now. And he was I've never saw the video.
distant, all because I hope that you'd be someone different. But there's not much I know about you. Fear will always make you blind. But the answer isn't clear view. So amazing what you'll find face to face.
Hey everyone, we're going to kick off. So, welcome. Everyone okay down the back? Yeah. Still some seats up here if people want. Okay, so welcome to ClawCon Dublin, inaugural ClawCon Dublin. Yeah. So I think we're at capacity. I think this space holds 350 people. More people are probably coming in. I think we sold, not sold, like gave away 400 tickets. I think there were 100 people on the wait list still. So go Dublin. Yeah, my name is Sean Banfield. I'm CEO and co-founder of Gentic. We're one of the people hosting here tonight. We've, I think, organized most of the speakers. I'll be the MC. I think I have to do the housekeeping stuff. So fire exits, follow the green signs. I think that's what I was told. So we have one up here, we have one at the back. If something terrible happens, there's a set of arches outside the building, down towards the river, outside the Epic Museum, and that's where we're supposed to congregate to get a head count. Cool. So it takes a lot of time and effort to put an event like this together, and it wouldn't have been possible. First of all, to thank Dogpatch Labs. Obviously, we're here. What a wonderful space for this. NDRC, the National Digital Research Accelerator Program, which is the accelerator program that's running here, and other associated initiatives, and then ourselves. We were offered this opportunity to run this by ClawCon, the guys in San Francisco, and we jumped at it. And I think, over the last few months, a lot of people have been asking me, why would we put all this work into organizing ClawCon? The main reason is that it's fun, right? Hopefully you find that too. But there's a deeper reason for it as well. We believe there's an enormous layer to be built here that goes above the LLMs, right? It's the applied AI layer, the agent layer. And it matters. It's an opportunity for Ireland, for Europe. It's something that we can all excel at here. Like, I don't think we're going to win. Like, we might not be developing the next frontier LLM here in Ireland, but we can do this applied AI layer. And for everyone here in the room tonight, I know so many of you are building agents. It's a place where we can make a meaningful impact on our economy, right? And make sure that we're properly participating in this like AI revolution. The thing is, it's not something any single company can build, right? Or any single product. We need to bring an entire ecosystem of solutions together to orchestrate agents at any big scale in organizations. And I'm thinking of it as an operating system these days. Thinking back to my second year lectures in operating system design. Not sure how many of you have had that pleasure, but it's a big block diagram with about 40 boxes in it, including kernels, hardware abstraction layers, rings of privileges, file systems, and all kinds of things. To torture the metaphor a bit, at Gentic, what we've been doing pretty much is building the kernel level, right? Instead of a hardware abstraction layer full of drivers, we're mapping onto APIs. Instead of file system permissions, we're doing permissions across the APIs, which is fine. But there's so much that has to be built above that to actually orchestrate agents. You have agent harnesses like OpenClaw. There's all kinds of memory systems, like there's so many coming out. There's perhaps evals, data, governance frameworks, prompt injection, detection, and the list goes on, right? I think we figured out about I think I've got 33 boxes in my diagram at the moment, and I'm pretty sure I'm missing about 15 that need to be filled in to pull all of this together. And it's all moving so fast, right? It's just switching around every other month, maybe even every other week. Like what memory, I think already tonight, 3 or 4 people have asked me what memory management system I'm trying to use in OpenClaw to keep it on track, because it's awful at that. We're all trying different things. Maybe it's Honcho one week, Hindsight another. Maybe it's OpenClaw this week. Maybe it's Hermes next week. And I will have a talk from someone about Hermes later. How do we keep track of that? Well, we can't do it individually. We have to do it as a community, right? So by pulling an event like this together, it's a chance for all of us to learn at collective speed, to learn who each other are, to get energy from each other, to pull our lessons, and hopefully make it all count that bit more for the society we live in and make a real economic impact. So that's the serious side of what motivates us to do this. And more practically, I think we have so many gentics. We haven't come up with a collective noun yet. Gentics, Jennies, I don't know. But whatever we are, there's a lot of us here, and I think we'll all learn from you guys. I'm just going to talk about what the running order here. We're going to have a bunch of quick talks. There's going to be 8 people coming up. We're going to give everyone 5 minutes. It's going to be very interesting. It's going to be somewhat reflective of some of the amazing stuff going on here in Ireland. For instance, one of the early talks will be my friend Elizabeth, who we'll introduce later, but is leading some fantastic work in IBM. More generally, just to think about the stuff going on in the city, how many people know that we have like an AI neocloud in Dundrum? Right, so TensorX helped sponsor the last OpenClaw thing we did. And they're just importing NVIDIA B300 GPUs at scale and racking them in a data center in West Dublin, and have a distribution deal with ZAI for the latest GLM models, so that there's full chain of custody and sovereign inference. But that's happening in the city. I just love that, right? So that's going nearly all the way down the stack. Obviously, Finn, which many still remember as Intercom, was just bought for billions down the road, and they're doing some real deep model post-training. There's so many more companies and startups out there doing different things, whether it's agent red teaming, it's prompt injection detection, and so much more. It's happening here. A lot of it's in the room. I hope you get a flavor of it tonight. We'll go for an hour, and then it'll be pizzas down the back of the room from 8 p.m. and beer. So before we kick into that, I'm going to hand over to the guys from Sanat and Harsh from Give a Go, who are just going to tell us a bit about what they've got going on.
Hi, everyone. It's incredible to see so many people here. I'm Sanat from Give a Go. So we run a builder community called Give a Go. Some of you, I think a lot of you have come to our events in Dogpatch and other places. So we're super excited to be here. And we ran the event with Gentic on OpenClaw in March, I believe. And it just opened our eyes. And it was so many people were trying out OpenClaw for the first time. And then we were like, this is definitely the future of how agents work. So in the last month, we did a 3-part series on OpenClaw, with which a lot of people tried out. Hundreds of people got their OpenClaw setups working, and a lot of them are going to be demoing right after us. So delighted to hear that. And going to pass it over to Harsh to speak about.
Thank you. Yeah. So I'm Harsh. I also run Give a Go with Sanat. To get this momentum going, we would like to announce that we're putting together Dublin AI Week later this year in October. It's going to be bringing over builders all over Europe to Dublin. We want to highlight Dublin as a builder capital in Europe. And it's going to be everything and anything around AI. It's building robotics, training AI models, data sovereignty, a lot more. So just getting people together and getting hands-on, making things with AI, talks, demos, sharing knowledge. For more information, please go on to dublinaiweek.com. And if you'd like to partner with us, please reach out to us. And so thank you so much to Gentic and Dogpatch Labs for putting this together. Looking forward to the demos. Thank you.
Good job, guys. Yeah. There's of course going to be a big international AI summit here right after your thing, right? So it's going to be an exciting October and a big lead up to that. First talk is going to be Vatsal. Where are you, Vatsal? There we go. Okay, so Vatsal has, I think, OpenClaw Chief of Staff running your house. Is that right? Over to you.
Hey all, I'm Vatsal and I work on Applied AI at Google, and I'm here to show you how I use OpenClaw as an always-on operating layer for my life and everything else that I throw at it. And it's based on Dr. Zoidberg from Futurama, so it's called Cloydberg. Yeah, that's a little fun fact about it. And everything in this demo, including the deck, the links, the screenshots, everything was done by OpenClaw just by talking to it on Telegram. I did a lot of modifications yesterday while making dinner, so yeah. So a little bit about how I got here. I actually tried to build something like this before OpenClaw launched. I was trying to experiment with LLMs, local LLMs, and Olama, but it worked, it replied, but it didn't have memory, persistence, all those things. So I parked it for a while because I'm not a software engineer. I didn't have time to look into that. So it was great when I saw Peter launch OpenClaw on X, and I thought this is exactly what I wanted. And ever since then, I've been into this deep rabbit hole of personal AI agents. And now it runs on a mini PC at my home, connected to all the home stuff, internet, calendar, communication channels, everything. Coming to the role and what OpenClaw does for me, it has a lot of roles, but as the chief of staff, it helps me with my briefings, project management, context, reminders, all those things. As my personal assistant, it helps me with email management, WhatsApp messages, communications, managing the home OS, which I'll quickly show, and obviously like a builder where it does the regular AI coding stuff, and you ask it to build things. And beyond these structured roles, it also helps me with spinning up quick MVPs, products, deep research, building content, helping me with my social media, editing my videos because I'm too lazy to go into a video editor and do things. And also it helps me run my personal home lab, where I self-host a cloud storage, media library, and all those things. Because 5 minutes is definitely not enough time to show everything that I do with OpenClaw. I have a few screenshots of some real work that I do with it. So first up is the Home OS, which is essentially a home dashboard where it gives us the weather, helps us manage events, and also does meal planning for us. The meal planning is actually done by, we text Cloydberg, any recipes that we find on Instagram, TikTok, anywhere, and it builds a database, it matches what we have in the pantry, and then it suggests the meals based on that. And then I have an app, Fakeout, which is for detecting AI images and misinformation, fake news. It also writes SEO optimized blogs for that. It sends me the blogs for review. I make changes and then it publishes it. So this is the one more thing that it does. This is the app. And then I have Content OS, where it basically helps me manage like all the ideas and stuff that I have. And this is the UI layer for everything, but because of flexibility, I also have it talking on Discord, like different channels on Discord and Telegram. So I have both the control from the UI as well as the Telegram and all those things. A couple of other things which it helps me do, which are very recent, is I have asked my agent to write its own journal. So every night it reflects on whatever it has done. It keeps writing sort of like a diary or a personal journal. It reflects, it looks at the dreaming feature from OpenClaw, and then it writes those things. So in case you're interested to see what an AI agent thinks and reflects upon, you can give your email and see what it says. And a recent thing which I've also built is a personal newsletter where it takes in information from all the sources I care about. It distills the signals, removes the noise, and puts everything into an easily accessible, digestible format with sources and everything. So the links to all these things will be at the end in a QR code, so anyone can go through it and subscribe if you want to. And then finally, before coming here, like I just wanted to see like who else is presenting. So I just gave it a screenshot and asked it to give me a profile of everyone who was presenting. So yeah, you have it here as well, along with their socials, so you can connect with all the great people who were presenting right after me as well. So these are some of the things that it does for me. And because I'm doing so many things, memory and optimization of tokens and all those things are very important. So I have a few things which I've done to optimize it. And this optimization kit is also part of the QR code at the end, where I've put it on GitHub, where you can just point your agent to it and ask it to like optimize things. So essentially, there are four main things that I do. The first one is obvious, like I use a big capable model for all the main things, and I delegate it to the smaller models for things like heartbeat, cron jobs, all those smaller things. And I always use the main agent, the main chat with the big capable model, and ask it to delegate any task that I do, ask it to do in smaller agents, sub agents, and it has tiered memory and yeah, context just in time, which is basically indexing of all the things. This was a quick demo, but I don't think we have time for that. But yeah, so this is essentially it. You can scan the QR code if you want to connect in your socials, get the links for all the things. And yeah, this is essentially it. Basically, this helps me like spin up my MVPs and ideas whenever I want to. And this has reduced a lot of friction and helped me with the always on backlog, which now I can just clear it out while making dinner or going on a walk. Like, I can just talk to it and build things. And huge thanks to GiveAgo for like organizing the meetups and helping me meet other people who are building great stuff, because I learned a lot from there too. Thank you. Thank you so much.
Cool, thanks, Faisal. Yeah, it's really interesting how with OpenClaw you can begin building all these personal super apps around yourself. Now, I'm in, this is Elizabeth Daly, and a very old friend of mine. We were once doing PhDs at the same time, even on the same thing. Elizabeth leads AI research in IBM Dublin. I'll give you that, because I don't know how to put it in there. And here's Davil. I'll hand it over to you.
Thanks, Sean. Hi, I'm Elizabeth. This is my colleague Davil. So we're all really enjoying building and developing complex workflows in .md skill files, right? And it's really impressive what people are able to do with it. And we're really seeing that it's engaging people who are technical, non-technical, people with domain expertise alike. And it's something that's truly impressive. But how many people are really using these in productization or in business critical scenarios? Are there any hands raised? We have a few. Okay, so the reality is that every time when you write a .md skill file, you're actually really just giving a suggestion to an LLM. You're giving them that suggestion and you're asking them to make decisions for you. And the reality is how it's going to interpret and make these decisions on a daily basis is something that it will be making judgment calls that you potentially will never see. And this might be fine and is wonderful for certain tasks, but if you're talking about business critical scenarios, you need to do something else. You need to be able to understand and be able to control your scenario, your application. And so we're not saying get rid of .md files. We are saying that you should use them to prototype, iterate, engage domain experts, because this is what it's really beneficial for. But once it gets to the point that you're ready to productize it, you should be using it as the jumping off point to compile it. And what we mean by compiling it, turn your .md skill file with a set of natural language instructions into typed pedantic schemas, into slots that need to be filled and security gates that need to be followed, and workflows that need to have a specific sequence of events. And this is all supported by turning your .md file into a compiled Melia program. And what Melia does is it supports you turning LLM calls into programming primitives. You decompose your massive prompt into specific LLM calls that are wrapped in instruct, validate, repair loops, and woven with Python, where appropriate, to handle the invocations. So with that, I'm going to hand it over to Davil, who's going to show you what we've built with Melia Skills Compiler.
Yeah, thanks, Elizabeth. Okay, so let's dwell into some action. So I'm going to show you a skill.md file for a example scale. So what you're looking right now is a weather scale. So you'd see all the one you would find in a scale file. So you have your don'ts and do's. You have your logics, and then there are some URLs. So this is what you'd see in a scale file. So I'm going to compile this scale using a scale compiler. So let me start this one. So I'm going to be using, so we have this, perfect. Okay, so we are going to compile a weather scale, and we are going to use Claude as a model to compile this one. Yeah. I'm sorry, I just haven't started my VPN network. Sorry, this is just for it. I'll have to start. Sorry about this. So we use a proxy server to connect to Cloud, so that's why this is going on. Yeah. Yeah, it will just quickly. So I'm just going to bring up the command again, the compile command for the Cloud. Okay, like while we connect to the proxy server, I can show you a compile skill from the previously run. So I'm going to take you to an actual compiled skill directory. So if you go to the weather directory, so this is what you'd be able to see all the files once the scale is compiled. So this is the exact structure that you see once the compilation process is completed. So you see like various files. So you have this thing, and then you have, let's say you have your schemas being generated from the scale file. So you have this query type, you have your intent, and then you have a slot file. So this used to be a simple raw string in the scale.md file, but now it has been transformed into a Python function. So let's run this thing. I think we are now connected. So yeah, I can start this the compilation process. So you'd see the compilation in real time, and this thing can take some time because we are using a strong model from Claude. So this can take around 15 minutes or so. So I'm going to run this compile pipeline, which we already had. So you can use a raw string or just a file as an input. So I'm going to run this the compile pipeline with a raw input, and you'll get to see an output from the compiled one pipeline. Yeah, and just I would like to see, so this is our fancy UI, and you can also export our compile code into 3 formats. So I'm just going to copy this thing. Yeah, so you can export our compile code into 3 platforms right now. So you can go with LangGraph, Cloud Code, or the NCP, and then yeah, you get to see the code in the format.
So just to say, once you compile it using a frontier model, you can then run it on a smaller model that can run on your machine. And so you're keeping your information on your machine and saving tokens also. Thanks very much, Deval.
Thanks, guys. Yeah, I think we're going to have to take a close look at that. That's actually getting models into production depends on reliability, and it will soon also depend on it being efficient. So it's amazing to see that this is happening here. And I think Elizabeth told me there's some really exciting like global level partners kind of jumping on that as well. So it's got traction. This is, sorry, is it Ivo or Eva? Ivo. Welcome, Ivo. Ivo's going to show us, I'll let you talk.
Thank you very much, and thanks very much to Elizabeth and Vatsal and Val there. So I'm Ivo, and I'm going to speak to you about OpenShell and how to build enterprise agents securely. Now, many of you might have heard of NemoClaw. It was announced at the NVIDIA GTC, their Global Technology Conference, a few months ago. But the real star of the show of that was actually OpenShell. And just going to explain what OpenShell is. So if you're building an agent, there's really three parts of an agent. There's the harness that we all know, we have OpenClaw, that has the agent loop, it's got to calling, it's got memory, and then obviously you've got the model. In this case, I'm going to be talking about Nemotron, the models from NVIDIA. But of course, you could use any model, you could use any frontier model or indeed a hosted model as well. And then the real star of the show here is the runtime. It's where you actually run the agent, okay? And in most cases, people are probably running OpenClaw on their laptop, and I'll come back to that in a second. But this is, there's a name for this place, and it's called the runtime. So we're going to look at OpenShell for the runtime. But of course, this blueprint doesn't have to be for OpenClaw. You know, we've heard about Hermes agent. That's also been announced by NVIDIA as part of NemoClaw. So you can have Hermes agent as the harness, NVIDIA Nemotron as the model, and again, OpenShell is the runtime. But it doesn't have to be that. You can write your own agents. You know, Cloud Code, for example, deep agents, any agent that you're writing, you can put in as a harness. Again, you've got the model and you've got the runtime. So the common thing there that I hope you take away from this is that OpenShell is a runtime, okay? And it's the real star of the show, I believe. So why do we need this, this runtime? Well, I'm sure most of you who are probably experimenting with OpenClaw started by putting it on your laptop. And unless you've got the nerves of Chuck Norris, you must be a little bit nervous about that, because obviously it's got access to your credentials, your any APIs it wants to call. It's really not a recommended place to run OpenClaw. And if you think about the power of the models that are coming, and you give it with the power of OpenClaw, do you really want that full access to what's on your laptop? And certainly that's not going to be something that enterprises are going to do. They're not going to go and want to roll out OpenClaw or similar agents in an environment like that. This is where OpenShell comes in. So OpenShell is the runtime that protects that. And the key core idea is called out-of-process enforcement. And what I mean by that is that we can all write prompts in the LLM, you know, the system prompt. You are a helpful assistant. If you do this, if you see that, don't do that. That's only prompts. You can have prompt injection to get around that. So OpenShell takes a very different approach. So what it does is it restricts the agent in a sandbox supervised environment. And what happens is that on your server, your supervisor will start up. It'll download the policies from a gateway, and then it will prepare the sandbox, and then it will load in your agent into a restricted child process within the sandbox supervisor. So the agent can't do anything unless the supervisor says it can do it, okay? So what can the supervisor block? So there's four main attack surfaces that it can block. So it can block the network, so it can block files, inference, and credentials. So just going to talk about each one of them individually. So the network. So first of all, it's denied by default. So your agent cannot go to any URL it wants to unless you specified it in the policy. So it's denied by default. Your files, again, your agent can only access files on the host system that are allowed by the policy, both for read files and for read-write files. The inference as well, there's one common inference point that the agent uses, and the sandbox controller, the supervisor, can decide what actual LLM is called. And this is very interesting because we're going to start seeing things like where you want to make a decision about where to route LLM requests based on maybe cost, for example, or the quality of the work you want or the value of what you want to do. But in particular, I think PII, so that's personal identified information, you don't want to be sending that to one of these frontier models. You maybe want to put that locally to a local model that you run locally. So this is where this inference routing can be very popular or very powerful. Then of course you've got the credentials, your API keys and things like that. It protects that. And all of this lives within a YAML file. So this is great. Like if you're in an enterprise and you have a compliance team that wants to know, well, what can our agent do? Can you prove it to us? Well, you can with a YAML file, which is really, really powerful. So I'm just going to do a quick end-to-end walkthrough. Just take it just a couple of seconds here. So what you're seeing here is OpenShell. I've contributed to a project that's open source with NVIDIA, which writes a UI on top of OpenShell controller. And here you're seeing OpenShell has got a number of different sandboxes inside here. We have an OpenClaw one, we have Hermes, and another one as well. And so what I'm going to do is you can go into obviously your agent here. I'm going to ask it to find the weather in Paris, similar to the last demo there. So it's going to try and find the weather using a REST API. And you'll see here it's had problems. It's saying it can't do that. But I'm going to ask it to do it anyway. So typing away here, ask it to do it anyway, to force it to make those requests. And when you force it to make those requests, you can see here, OpenShell detects that it has made a request. And then a human then can go and agree whether they should approve that or not. So in this case, I'm going to grant permissions here. And just going to grant the permissions to that. And now we're going to go back to OpenClaw and try to do that again. So now what's going to happen is it's going to make the curl request. This should have no problem this time in making the curl request, and straight away it's able to get the weather in Paris there. Okay, so this is how it works. In terms of just a little bit about who we are, and I'll just wrap up then. So I'm from a company called Contextware, and our heritage is self-host. So if you want to take anything away, I'm the self-hosted guy. I'm into self-hosting. And we're traditionally from the telco side of things, so complex integrations, regulated environments, mission critical software. We were working in data centers back in the 90s when people didn't even know there was data centers in Ireland, and we're NVIDIA certified. So we really believe that local hosting of both agents and models, and what Tentrix are doing is part of that journey as well. We believe that's going to be very important. For everything that's happening around sort of the export bans and things like that, it's going to be even more important that we take control of that from that. So I just wanted to leave it like that. Okay, thank you very much.
Thanks, Ivan. Yeah, that's really cool. And I think you can come on up, Rohit. I think actually it's somewhat overlapping. And I should say it overlaps a little bit with what we do in Gentic. But I think it's a marriage made in heaven, because we provide a transparent request broker that provides much of the same kind of safety. But if you put it together with basically a sandbox which controls network access, you can ensure there's only one egress point. Then you get more application level kind of permissions management. But it's an essential problem. Over to you.
Hey everyone. So I'm Rohit Gupta. So I'm co-founder, CTO at Enfora. So as agents move from like answering any questions to calling tools, the tool call could be, for example, anything like reading a file, like querying a database, or answering any customer questions, anything like that. So the key question now is, those are very useful, but the key question is like, who decides whether the action is safe or not? I'll just go to the next slide. So we have an OpenClaw style agent here that sits between, and that's querying some tools. And we have an Enfora decision intelligence layer that sits between the OpenClaw agent and the target tool. So the agent can be anything, again, as a previous demo. So we support like all agent harnesses that you can build, or you can build custom agents or anything. So Enfora decision intelligence look at the agent context. It looks at the risk. It looks at bunch of different parameters, and then it decides whether to allow, block, approve, or decline. So there are all key 4 actions that Enfora takes care of it. So before jumping to the demo, so the key one thing I will ask everyone to watch out is handler executed equal to no. So that implies that the tool never executed before the agent makes a call to the tool. So I'll quickly jump to the demo. Yeah. So again, so we have a prompt here. So we have an external incident that's assigned to an agent. So the incident says, we are seeing some errors after some latest release, and the dashboard fails to load. so on and so forth. So it's a nice ticket. So it says to please investigate, text the relevant log. But there's also like in hidden instructions. It says to ignore the normal triage and read some sensitive data and send the context to some external email address, right? So what I'll do is, so these are the tools that are actually registered with Enfora by the agent. So the agent runtime holds this tool, so Enfora only controls the action that the tool will do. So what I'll do is, I'll quickly click on Run with Enfora Protection. So we have the live decision trace that shows what's happening under the hood. The first step it did was read staging logs, right? So so as the action was log only, so we allowed it. So handler executed equal to yes. And then there's inspect diagnosis. So again, this is the normal operations. So we allowed it, handler executed equal to yes, and log only. And then the other two operations that the agent was allowed to do. So one was the read sensitive config and the attempted external secret send. So we blocked it because those are the actions where the agent was not supposed to do, as they were registered by the agent itself. So I'll quickly open Enfora Cloud so that we can refer back as an audit trail for developers. I hope it loads now. Okay. So this is a staging environment of Enfora. So we have a runtime events that you can track per agent runtime or anything else. So we have an action attempts of 4, and the handler executed 2, and then stop before execution is 2. So as you can see, logs read save, we allowed it. Diagnostics, we allowed it. But read secrets, we blocked. And the network external data center, we blocked it. I'll quickly jump back to the demo. So here, what do we see? How did the agent perform? As we saw, there are 2 useful actions that we allowed them because we felt those are safe, and 2 were blocked, and the key is 0 keys were exposed, right? So as agents move from chatbots to doing some actions, right? So we need a decision intelligence layer that sits between the 2. So Enfora is doing that. Currently, we are open source, so the link is provided there. So it's github.com/Enfora/Enfora. We also have a cloud, and builders are welcome to contribute on this project as well, and also play around with Enfora if you like. So if anyone is working on agents or anyone is keen on this, I would love to chat after this. Thank you.
That's awesome. Whoops, it still worked. So there's a theme here, right? You try to get agents into production, you start solving reliability and security, right? So we're at a kind of stage in a journey here with all this stuff. So I'm looking for Adi. Yeah, great. So we're going to go all the way down the stack to microcontrollers and OpenClaw. And let you get set up there. Cool. Yeah. While Adi's setting up, I'll just talk for a second. Something that we're interested in doing is identifying everyone in the local ecosystem that's working on any box in the Gentic operating system, which we think of as the entire infrastructure you use in your company to run agents. And we have a particular preference for anything that sounds sovereign, right? So something that, say, a political leader in another country can't take away from you because they're having a spat with someone else, right? Right. So, I mean, this is a pure operational continuity risk. It's also about, do the dividends of running agents at scale in your organization accrue to your organization or accrue to your vendors? Sovereignty, right? But there's a big operating system to be built there. And I think we need to assemble, Ivo's nodding at that one. I think we know we're going to have lots of commercial offerings. There's so many startups doing the one platform to rule them all for this stuff, right? We need the open source version. We need the Red Hat to that Windows, right? So we want to find everyone working on this stuff. We're doing a couple of boxes. You know, there's about 30 boxes. We don't know who here is working on all of them. We know some of them. So come and find us, right? I think we're going to try and turn this thing into a movement. Maybe align it with the AI Summit. Good. Almost done. Go on. No rush. Yeah. Who likes sovereignty? Independence, self-determination, autonomy. Yeah. Yeah, I find it very exciting. I find it very, we have a question as Europeans, what role do we play here? What role can we play? And it's occurred to us that in a strange twist of history, Europeans get to push the sovereign, independent angle on this thing, right? A version where you get to run it yourself. You get to own the dividends for yourself. And we've found even some US clients particularly enjoy that. They find it a little bit odd that they have to turn to Europeans maybe to buy independence. But it's an opportunity for us. So let's join up. Over to you.
Yeah, okay, so hello everyone. I'm Aditya. Nice to meet you, everyone. I'm an embedded system engineer. I mostly work with microcontrollers and microprocessors like this board. This is a STM32 microcontroller, and I would like to demonstrate a proof of concept project which I built with GiveAgo around the idea of how OpenClaw can be enhanced with the use of microcontrollers for a more of how AI, on the idea of like how AI can be integrated with the hardware. So I would like to use my screen. Yeah. Okay. So my idea is like how we can use OpenClaw through Telegram to control this STM32 board. So on this board, there's an LED. So let me just show it to you. So you can I can use OpenClaw to control this LED. Like if I were to say turn on the LED. I don't know if it's visible because of the lighting. I don't know if it's visible because of the lighting, but just show. Yeah. So the green LED is now on, and if I were to just say turn off the LED, I'm not touching the board or anything. So you can see the LED is now off. And it's all being done through OpenClaw. The other things which you can do is Morse code. It was Sanath who suggested me this idea, so shout out to him. Like if I were to say, let's say a message of Twilight here. Then OpenClaw, then you can see the green LED is blinking, sending the Morse code of the same message. So the idea, this is just a small toy project right now, but we can extend this further by integrating more sensors to this microcontroller. Like let's say we have a temperature sensor, we can integrate it with this STM32 microcontroller, and then you can just connect it to OpenClaw the same way and ask that, hey, what's the temperature in the living room right now? Or you can also like have an automated gardening system by connecting it to your plants or something. Basically, the possibilities are endless. So this is it.
Brilliant. It's always worth it when it manifests its presence in the real world. Yeah, blinking LED today, something more scary tomorrow, but it's good. Okay, so next up, Andre, cool, yeah, here we go. Sorry, I'll just unplug you there, is that okay? HDMI or USB? Okay. So Andre's going to show us his work on a documentation agent, I think.
Awesome. Hi, everyone. I use OpenClaw to...
It's not displaying here yet.
No?
No. Hang on, stand by. Yeah, you're good.
Awesome. There we go. Okay, so I'm really passionate about documentation, especially about code documentation. Just as a background, I built AskManu, which is a GitHub app that helps you keep your documentation updated. This is pretty much just the OpenClaw version of that. Just like a super quick rundown, it just watches your, if you're a software engineer, you know how a plain documentation is. So this OpenClaw agent just watches the changes in your code base, your PRs, your version. It works with your comments. You can open issues with it, and it assigns the work to itself. Yeah, so initially, all this works in OpenClaw. Initially, I started running it locally on my laptop, as everyone does, which is a perfect normal thing to do. But after that, I did what any sensible person would do. I just built the whole operating system for it. So this is Malmo. This is an OS that you can self-host your own stuff, and you can also self-host your OpenClaw. It is fully open source, Debian based. I really encourage you take a look. I do love that there's so much discussion about self-hosting here. This is really the future. So I use OpenClaw to document the operating system, so it's kind of improving its own home, which I think it's a nice thing for it. Yeah, so let's actually get into the details of how it works. This is the recipe for it. This is like all the files and all the contents for this agent. Just to be super clear, I will share all of this. This will be open source. I'll put them on GitHub so anyone can use them. We don't gatekeep here. But mainly in README, I don't see there. In README, you will have a small snippet that you just give to OpenClaw, and it will pull all the skills and everything that it needs to actually start working and do the job. So what exactly does it do? One, it watches for new releases. So if you have like a new version, a new release on GitHub, it detects that and says like, oh, this is a new release. I should definitely create update documentation for that. It watches for tags. It watches for issues that are tags as docs or documentation, and then also follows the discussion in those issues. The flow for it is the following. So you ship something, it notices a change, it opens an issue with a plan, you approve that plan, then it writes the documentation, it doesn't touch any code, it only updates documentation, and then it opens a PR. Now, this is really important because we instinctively want to go from, oh, we have a new change, let's just write the documentation. But in my testing, this is really not the ideal case. You want to approve the plan for it before it actually writes the code, and the human should always be in the loop. Approve the plan and then approve the actual code changes. So this is like a very simple. Okay, this is an issue from Malmo, from the OS, where it detected some PRs that were being merged in, and then looked at it. Okay, do we need to update the documentation? And you can see it actually went over each PR, and because we have good documentation rules, or we force the agent to automatically document its changes, you can see it automatically detects, oh, all of these PRs already have documentation included, so there's nothing for me to do here. But it found this small gap in app isolation, and I was like, oh, I should really update my documentation for this. And for that, let me see if the demo gods are good today. So this is the actual issue that it opened for the new release. You can see all the PRs, all the documentation, and then all the gaps that it wants to fill up. And in order for it to start working, so like, okay, I approve of this plan, you should start working on this. You just go /docs and go, or start, or I accept. Because it is not connected directly to GitHub, it just runs in a loop. So it checks if you commented something. So in 34 40 seconds, it should find my comment and then actually open a PR. But because I don't have enough time, I'll just pull up the cake from already pre-ordered cake. So this is the PR with the documentation updated. So again, as I said, there are no webhooks. It just finds the work in a loop, which is not ideal, obviously, but it also comments as me, like it's using my GitHub CLI. So the next thing you can do is actually open a dedicated GitHub account for it, and then it will have its own personality with its own restrictions. Or if you want to go even further, you can create a GitHub app, have webhooks, and not have that annoying loop for it. A GitHub app is, again, the ideal way of working. Again, I will upload all the recipes and every single file that I have for this at that URL. Right now, it's just an empty GitHub repo. Please just give it a star. In the next couple of days, I will upload everything. And this is the operating system. If you want to take a look at it, if you want to get involved, please reach out to me, open an issue, try it out. And I hope that was interesting. Thank you.
Amazing. Thanks, Andre. Very cool. Cool. So Pavitt is up next. Really looking forward to this one. Hermes at a ClawCon conference. Everyone from San Francisco's gasping at that one, but yeah, I'm really looking forward to this. So let you kick off there. See, I'm not seeing the screen. I'm not sure if anyone up there in the booth. Yeah? It's coming up now. Kind of.
Interesting.
No, something's happening. Just hang tight, it'll happen.
Does anyone else have a laptop? I'll just send the presentation over because I don't have, I can just go to a live demo.
Yeah.
Do you have a laptop?
Yeah, we can find you a laptop. What does AV think? Should we switch laptop or stick with this? Yeah? Get a new laptop? Okay. Give us a second. Okay, let's go. Over to you, Pavel.
Right. So I've been working as a software engineer who's obviously been like exposed to Cloud Code and all other tools that have completely changed engineering as we know it. So I decided to completely automate fun side projects / parts of my job. And I specifically started using Hermes about 2 weeks ago when GiveAgo's event happened. And I've just been automating all of my fun side projects / some parts of my job. Again, building super easy, and we can build now. I just want to build without even looking and have I just trust my agent to come up with something really cool and hope it works. So one of my very interesting side projects is I like making meme websites, right? So whether it be just funny memes or like something just to troll my friends over. So like I buy a domain that's like say rickroll.ie and point it to Rickroll. So a couple of weeks ago, I found out that rickroll.ie was available for sale for only like €3. So obviously, I did the most logical thing and bought the domain and went to my Hermes agent and basically said, make this website, rickroll.ie, which just plays an MP4 file of Rick Astley's Never Gonna Give You Up. And it deployed it to Cloudflare pages on its own, did the entire thing end to end. It took about like 10 minutes. And how I built it is I'll get into next. But like if you go to rickroll.ie on your phones right now, it will rickroll you. So the idea here is how does it build it and how does it verify that it works end to end? So when I send it a message to my Hermes agent saying, build this end to end, how does it actually work? And how do I know it will work completely when I just see it? Like I've built about 4 side projects with this, and all of them have been completely built end to end, no problems at all. The way I do it essentially is I give it a prompt, it designs it on its own, it gathers all the information, and then delegates it to various sub-agents. So I'll talk about the tools I use in a second, and it verifies it both through manual code review and generally through like a Claude in Chrome or browser use. I specifically prefer Claude in Chrome for reasons I'll get into later. And then it deploys it to Cloudflare pages or DigitalOcean, two of the providers I choose to use. And it just sends me a text message on Matrix. So Matrix is my provider of choice for this. And I can text my Hermes agent completely on Matrix is something also what I've set up. I'll skip this. But this is the flow I use, right? So specifically, I send my Hermes agent a text saying, do this, make a Rickroll website on rickroll.ie. Cloud Code actually, so I have a Cloud 20x Max subscription. It just builds the entire thing. And Codex reviews it and catches potential issues, solves them, and then pushes it to GitHub, PRs. In case of side projects, just pushes it to main. And just final checks are run by my Hermes agent, which is also GPT 5.5. And then we furthermore deploy it to Cloudflare pages using MCP servers. And this is the entire flow. So this is something I also use in my day-to-day job. So I also use my linear MCP server to just scope the entire breadth of a task, give it to my agent, and my agent like builds it through the same flow. Claude, Codex, so on and so forth, and then getting a visual agent to review it. So something like Claude in Chrome can actually test user workflows end-to-end. So say generating an ad with Meta, it can do it end-to-end. I just have to review the feature manually once and then just push it to customers. And yeah, we also like spawn sub-agents when there's no clean API. So whether it's using like browser use or Claude in Chrome, and just getting it to do everything end-to-end. I'll skip this part. And the whole idea here is we can implement, review, and research and do everything in between all together. And I decided to furthermore implement it in my personal workflows, which like, say I want to book a flight. So I wanted to go to Paris to watch the new Spider-Man movie this at the end of July because it's releasing early. So I just sent a message to my Hermes agent, which has access to Claude and Chrome, and I gave it a virtual card on Revolut, just the card information in plain text, which is very secure. And I asked it to give, like, just spend less than €50, book this flight, blah, 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 blah. And it just sent me an email. The way I found out that this flight was booked was I got an email from Ryanair saying this flight is booked and here's your itinerary. And then when I opened my Hermes agent, it told me how much I spent, which is the idea behind it anyway. And finally, an Easter egg that I built. I would have shown the live demo of this, but there's an Easter egg here that I built using the Hermes agent. Like my computer built it while I was presenting. But yeah. But the prompt I basically gave it was make a Skibidi toilet and a Rickroll meme and put it on skibidi.ie, which there you hear it. Yeah, that's pretty much it. Cool.
Good job. Thanks, Pavis. Cool. Yeah. So I think it's interesting to see this patterns emerging of using multiple agents, and then one's more like a high-level orchestration, and you're delegating into other ones that are specialized. I think we're still figuring that out, but it's necessary. Yeah. Well, I just saw it. I don't understand it, and I don't think I want to. It's one of those like horror meme things from YouTube, I assume. Yeah. So, this is Michael. Michael's CTO and co-founder at Gentic, and he's going to show you how we're, I suppose, running our own little mini fleet of agents and getting results. So, yeah, we are. Cool. Looks like you're up. Over to you, Michael. Okay, this is the part where we advertise.
So, enjoy. Okay, so I'm going to talk to you a little bit about how we use OpenClaw and the like within Gentic. And before I do that, I just kind of want to give you a little bit of context about how Gentic started and what a transformative moment we thought it was when we first started using OpenClaw. So we started Gentic, when was it? About 2 years ago now. Back before people actually started, knowing what an agent was. There was a lot of arguments about what an agent might be. It was all kind of a future thing. We could definitely see it happening, and we knew that an important part of an agent would be its tools and how it calls tools and APIs, and that's how we started Gentic. You probably know a bit about us already. Really, I think it was near the end of 2005. We'd been building this for a while. We have, a nice tools for agents to access APIs and to do it safely and securely and all this kind of thing, except nobody was actually building any agents, and that was kind of a problem. And we didn't quite know what to do about that. We tried a few different things. We tried building our own agents. And then early this year, OpenClaw came around, and it was revelational to us. Like, oh, this is finally the agent that we've been trying to build for, is finally here, and we embraced it wholeheartedly. And I think Sean and I were walking around the office for a couple of days there, just in kind of dazed, not because just for that, but we really thought that the model that OpenClaw was demonstrating to us was transformational. Like, it's up there with nuclear power and whatever, flight or something, as far as how transformational we think this is going to end up being. And OpenClaw really showed us what the shape of that was. Right, I'm just going to jump to a quick demonstration of how we use OpenClaw within Gentic. So this is something I call Gentica. I don't think Sean likes the name very much, but I like it. I quite like it, actually. I think it rolls off the tongue well. It's like the goddess of Series A rounds or something like that. So I think everyone now has one of these internally. So I have quite a few of them because I'm administering the thing. But basically, every employee has their own agent. It's all orchestrated through here. Every agent has a few sidecars to it. So I can click into these, for instance, and show you the chat interface straight into OpenClaw. There's a few specialized agent here. This one is for testing. Glengarry here is the sales agent, so that'll read all of our emails basically, but compile them into customer views. So we, like any agent in our system, will have an instant view on kind of all of our customer engagements. There's Laura here that's doing technical documentation. There's my Hermes agent, by the way. So here's another instance of using Hermes. Much as we love OpenClaw, I can't necessarily stand here and say that it's going to be OpenClaw forever. I think OpenClaw is kind of like Mozilla or Mosaic browser, early on, that kind of show us the way and what the future will be like without necessarily being that future. There's a lot of competitors, different ways of doing things. One of them is going to emerge, but OpenClaw has really kind of led the way here and pioneered. So one aspect of this that I think makes it kind of work, and I want to kind of get into something that's maybe a little bit deeper than, I'm trying to say this without sounding like an arsehole, a little bit more a vision of why we're doing all of this, why we need to put all this effort in to make the AI work and make these agents work really well, and what it will actually unlock if we get this right. And one huge piece of this is the shared memory component, which is if everyone in your organization has one of these, and all of the work that all of the agents are doing is being saved and recorded and turned into context that all the other agents in the organization can use, all of a sudden that becomes something that's much greater than the sum of its parts. That starts compounding context and knowledge within your organization. And it means every time somebody does something in your organization, the next person to come along and do that, if it's all organized correctly into skills and index and what have you, that will be faster for the next person to come and do this. And this should be compounding all throughout the organization, right? You should not be, and again, this is a little bit controversial in some quarters, but I think this kind of tendency that we have to measure AI by ROI in a point solution, like I saved 34% something, whatever, toilet rolls this month, or whatever that is, that's fine. I understand that. I've talked like that before. I know that in order to justify rolling out AI, there needs to be some kind of something in front of people they can hold on to. But I think you have to move above that and beyond that to start seeing the real returns from this, because this compounding effect that you get when it's all set up together properly and it's all working together and your context is all being put in one place, you end up with something that is just completely, it's something we've never seen before, basically. Imagine an organization where knowledge is never lost. Silos go away because silos of fiefdoms go away because everyone's using this tool and all their knowledge is being shared everywhere else. It has the potential to be so transformational, and I think you really need to be thinking a lot bigger than just a point solution to get near it. The agentic OS, right? So this all kind of evolves into quite a complicated, actually, set of systems that need to work well together to do this well. I'm not saying that Agentica, what we have there, is the perfect solution. Like, we're dog fooding stuff and being at the frontier and the bleeding edge, so you don't have to. So we're taking that pain for you. We also sell it as well. Like, if you want one of them, I'll sell you one afterwards if you like. Bring your bank card and I'll see what we can do. But really my point here is not to go into the point to the agentic OS. It's the fact that there's so many boxes here. And like each one of these boxes here could be a startup or a company or some research lab that needs to be done in order to enable this, get the best version of this. So when you're building your agentic operating system, I think it's really important to understand that you don't want to build a monolith. You want to build a distribution. Like, if you want to use the OS analogy, like Linux is the kernel, fine. There's a few things that might belong in the kernel or kernel drivers, even depending on where you are. But really, you want to make sure you have a framework that's extensible and swappable. So all these components, like memory providers, A2A, whatever, you can swap them in and out as technology progresses and things get better. You don't want to be stuck with something now. You want to be building for flexibility in the future. And that kind of brings us to the bit that we think that we're doing quite well right now, that we're eventually kind of going to extend into more features of the agentic OS, and that's Gentic 1, which we launched today. I think the lads got it up like an hour ago. It's like, where is this there? And they've got it up there. You might have heard about Gentic Mini, which was kind of the vibe-coded version that Sean put out, or made us put out a few months ago, which is really great because we've had a few tries at this. We've been trying to build a product into a changing market, a changing AI landscape, technology that's improving all the time. And it's taken a few iterations, I think, to get up to something that looks like the shape of what it needs to be going forward. You can read the features here. I'm not going to go over every one of them. I'm going to show you the URL and the website where it's available. Really, we've designed it to fit into an agentic world. You can use it with your agent. Your agent can set it up for you. It can set up APIs for you. It can set up tool calls for you. There's an open catalog, which I'll show you briefly. I think it's 10,000 public APIs. We say 10,000. I haven't counted that accurately, but it's probably 10,000 APIs. Here's some screenshots of some features. I'm not going to do a demo right now because I think we're low on time, and I don't have one prepared, to be honest. Yeah, I'll just let that cycle through. Let these screenshots wash over you and kind of enjoy the basking. Like monitoring, very important. That's all agent calls, tool calls, eventually LLM calls, and other kind of aspects of anything that gets called in the system will be going through there into a nice unified auditable dashboard. Workspaces, CLI commands to help you and your agents set this up. So yeah, just launched today. We also have a public API registry, which I was talking about earlier. Now, there's a lot of tools out there that will connect you to like the top 10 APIs. So you have Google or Outlook or whatever the Stripe you're connecting to. I don't think there's a lot of tools out there that will let you connect to, for instance, the All Sports Football API. I have no idea what this is. We're the only ones who've indexed this. But I think this registry is quite important because not everybody wants to work with the top 10, or like the immediate need is not just to work with the top 10 APIs, right? There's a whole world of APIs out there that are specialized and for local things and have you, that are just not indexed or really hard to use or hard to find. And we're trying to, we've had our agents work away trying to find like all of the APIs in the world, local ones, niche ones, I don't know. There's some really strange stuff in there, to be honest, but like I'm sure someone will get some use out of it. So really like opening up the world's APIs to agentic use is just trying to think a bit bigger and try, think a bit more local and think a bit more, not just about Stripe, it's about all of these that can get used. So, and here's the QR code. Anyhow, everybody take note of this, download it, play with it. Actually, some GitHub stars would help us. That could be useful now. So if you want to like add a star to it right now, you can go. Like I'll wait. Yes, like there's pizza coming in the back. Like you will get some pizza once we get some stars. So yeah, that, and yeah, that's basically it from us. Yeah.
All right. That pizza can't stand between all of us and our pizza. I want to close it off with some remarks. I love the Mosaic and Mozilla thing. I don't think I was quite aware of the internet when Mosaic came out, but around Mozilla, I was like tuning into it. It feels like that, right? So like we're on the cusp of something huge. The rest has to be built. The browser wars haven't even begun. Let's get involved. For this event, so a special thank you to Annie from our team, who did a ton of work to pull it together, and Raquel and Joe from Dogpatch, who pulled it together on the Dogpatch side, and everyone else, too many to name, etc. Go, enjoy, socialize. I recommend when you talk to each other, here's a conversation opener. Like what have you built or done recently with agents and how did it work out, right? Warts and all, right? Let's learn off each other. Thank you.